Hey guys, in this video we're going to cover how to plot data points and how to find the line of best fit all using Python code. Alright, let's get started. First I want to go over a little bit of background information before we begin using the Python code. Here we have the function y equals a plus bx. A in this case is the value where the graph intercepts the y-axis. B is the slope, and then x is just your x values of the data collection from the lab itself. So here we can look specifically at the slope, which is demonstrated by this massive and kind of scary equation. So let's just go through that real quick. We have the summation of xi times yi, which is your first x value times your first y value minus the product of the number of values that you have times x bar times y bar, and x bar here is just the mean of all your x values, y bar is the mean of all the y values, and then we want to divide that whole thing by the summation of xi, so your first x value, minus the mean of all of your x values. We take that, and then we want to square it, so that gives us the slope. And we can rewrite this original equation a little differently. We get the value where the graph intersects the y-axis, so we can say a, so that value, equals y bar, so the mean of all your y values, minus the slope, which we calculated from this formula, times the mean of all of your x values. All right, let's get started now on how to do that in Python code itself. The first thing that we want to do is open up Jupyter Hub, and that you can find in the link below in the description. And again, what we want to do is create a new file in Python 3, and then we can get started. So the first thing I'm going to do is rename this, and then I'm just going to call this sample code 2. Again, it would be helpful for you guys to rename it depending on whatever lab you're doing, but I think you got that. So the first thing I'm going to show you is how to insert comments in your code. So here we have a comment, and you know it's a comment because you have this little pound or hashtag symbol, and that just means whatever you write after the pound symbol is not going to be taken into consideration for when the code is actually run. This is just for you to make notes to yourself. All right, I'm glad we got that out of the way. So the very first thing that we're going to do for the lab is add in the import statements. Here, we're going to add in the following import statement. And this statement itself just helps us get all the functions that we need to actually plot the values that we have. And we can just use the object PLT to get all the functions in this library. Okay, so now that we have that, I am going to add in sample data. So this is just sample data that I'm inputting for your x and y values of your data table. And these are just an array of values assigned to a certain variable, so your y and your x. And again, this is just a comment for me, just so I know where I am at the code. And documentation of your code, so adding all of those comments is very good. It's a very good programming skill to have, and you should get in the habit of doing so. All right, now let's write our function itself. So what do we want our function to do? Let's just add in a little comment so we know what's going on. So we want to solve for the a and b values of, you know, that big scary function that we saw earlier that you can see to the right in this video? Yeah, we want to solve for the a and b variables right there. Let's define a function name. We can do this through the following. We type in def, so def. So that's just to define the function itself. This is the name I'm giving to the function best fit because we're trying to find the line of best fit. And then your input variable, so x and y, because those are our x and y data points, and then a colon, so we can write the function inside of that. So now the first thing that we want, if we look at our formula, is we want to find x bar, y bar, and the number of values. For x bar, again, that's just the mean. All we have to do is get the sum of all of our x values and then divide it by the number of values that we have. So sum and len are both the different functions that we're using to find the mean in this case. So we have the function, and then you have your input, which is your x values, and then for the y bar, we have the sum divided by the length as well. But the only difference is this time we're inputting all the y values instead of the x x values. Now, we want to find the number of different values that we have. In our case, this is pretty easy. This is straightforward. We can just count 1, 2, 3, 4, 5. We get n equals 5. But in your experiments, maybe there's too many. We don't want to get confused with the number of variables that we have or values. So we can just put in n equals the length of x. Now, what we want to do is we want to get the value of our big, scary formula for the slope, so our b value. And an easy way to do this in the code is to separate our different values for the numerator and denominator. So here's how we go about doing this. In Python, we want to make sure that everything is nice and aligned so that our code runs properly. This whole thing is saying finding the summation of our xi times yi for this range. So what this function right here is doing is just finding the value for the numerator of our slope. Right here, we're finding the values for the denominator of our slope. And then all we want to do to find our b value, which again is our slope, is to just divide the numerator by the denominator. And let's make sure everything is nice and aligned. So here we get b equals our numerator divided by the denominator, so the values we have for both of them. And now we got our b value. We want to find our a value, which we can do using the third formula that we have, which can be represented as a equals, so again, y bar, which we defined up here, which is just the mean of all of our y values, minus the slope, which now we just calculated from these three lines, times our x bar. So now after doing that, we can just print out our values right there. Now this is going to print out our line of best fit and then format it properly. So that's good. All we want to do at the end is just include a return statement. Now all this does right here is it just returns our a and b values, so then we can use them later on. The next thing that we want to do is actually print out our line of best fit. Now, this is going to be outside of the function itself. So this entire function right here that we just wrote finds the mean of your x and your y values, finds the number of values we have, finds our slope right here, finds our a value, and then essentially we do all of this because we are able to get the line of best fit. We want to use this function right here that we called best fit to actually find the line of best fit. So all we're doing is a comma b, so we're putting in our values and then it's going to plot it for us. So what we want to do to plot it right here. So again, we're just going to comment what we're doing, and then this line right here, it just tells our Python code that we want to plot all of our values. And then what we're going to do is we want a scatter plot of all of our x and y values. And then what we want to do is go in and we want to plot the line of best fit right here. And then this just shows us the different functions that we can have, so we can adjust the graph accordingly. So right here, this puts in a plot itself so that we're able to plot all of our values. Right here, this line shows us a grid. So once we output all this code, once we run it, we can see a grid. And this right here, this is a very important line because this makes it so that we can see all of what we are doing. So if we run our code, oh, look at that. So we get right here, line of best fit. So that was from this line right here. And then it just printed out. So they're just nitpicky little formatting tidbits. And it printed out our line of best fit right here. So that's exciting. And then we can see the plot. We can see all the different points, the line itself, and then our different values. All right, so there you go. The very last thing I want to touch upon is just including the different labels for all of your axes and the title of your graph, which is always very important. So we can do that over here. So I can say plt dot, it's just going to be title for the title of our graph. And then right here, so open parentheses, then bracket, and then I'm just going to type in sample graph, Obviously, for your lab, you're going to want a more indicative title. You want something that actually shows what you're plotting, but this is just an example, so this is fine for now. We also want to add in our X and Y labels. So now let's add X and Y axis labels. So all we have to do is plt dot, and then X label, and then whatever we want to call it. So I'm just going to call it X axis, and then do the same thing for the Y values. So plt dot Y label. There we go, spelled it properly this time. And then Y axis. All right, so let's run all of this beautiful code. See, there we go. So right now we can see that our graph itself has the x-axis, y-axis that we included and our title, but it doesn't have the graph that we want. So all we have to do to fix that is just rearrange the order of how we're printing everything out. So now if we run this, there we go. Look at that. What was happening before was creating the graphs, and then it was going through and then creating another graph with our labels. So just keep this in mind so you don't run into that error as well. So put all this in before and then plot all of your points and then have it print out your graph. I think with that, you guys are good to go and you have everything you need to start this lab. So good luck, have fun. Until next time.